Hello everyone, welcome to another video from my channel, and today I'm going to be talking about how I made my smart home talking to the cloud using Azure IoT. So a little bit about this video. So this video is all about a pet project that I've been working on, and the video is about just explaining my learnings throughout the whole journey that I went through, and all about telling you how to combine multiple Azure services and then showcase an example solution that you can put in using the Azure services. So let's go ahead and have a look at what the project is about. So as I said, it's about smart homes. So I was using Azure IoT to connect these smart homes to the cloud, and then collect the insights of the house, what sort of movements in there, how's the temperature varying, and etc. So for that, I needed some devices, and this all started maybe 2 years ago when I moved to a new house. And so as part of that journey, then I wanted to do some smart stuff within the house. So I bought this smart controller called Wear a smart controller, and then I also bought some devices that works with it. So this device, the smart sensor 6 from EOTech, collects a number of sensors. So it has a number of sensors built into that sensor itself. It's got temperature sensor, motion sensor, and humidity. Also a shock sensor built into that, and also the light sensor into that as well. So all of those sensing in one device. And also at last I've got the smart plug from EOTech again, which has the ability to turn on, turn off the plug based on the rules, and also has the ability to measure the current that's passed through the plug. So all these devices, and also I've got some DOW sensors as well, which I haven't listed here, but they all combine, and this whole thing started those days. Like, I did the configuration of the smart devices separately, and I had some rules working together. But this video is all about how we can use Azure to integrate this into the cloud. So how we can use is, like, we have a suite of services provided by Microsoft Azure in terms of IoT, like Azure IoT and Stream Analytics and machine learning and etc. So Power BI for dashboarding, etc. So all what this provides is the ability for you to quickly configure these IoT kind of solutions. And there are a bunch of pre-configured solutions that's provided now these days by Azure IoT, so that you can do those kind of solutions really easily and fast. So Azure IoT provides secure and reliable connection, and also ability to implement these kind of solutions easily. Also secure and reliable. Also it gives you support for broad range of platforms in terms of, like, implementing. If you're looking at, like, maybe a .NET application, you can implement, or you can download this SDK from the Azure IoT side of things and implement whatever the logic you want on the devices. But if your device is running Unix, or if your device is running like Python or something, then you can run or get the SDK from Azure IoT, and then get it brokered through the device, and get it connected to the Azure IoT hubs and to the cloud. So it gives you a broad range of protocols, and also supports on number of OSs as well. Also it provides the scalability. So if you want to start small scale and then do the large scale projects, then it has the ability to scale up easily in those kind of solutions. And the scalability is limitless. You can go to millions of devices connected, and we have number of use cases in those. So the project I did is following the Lamda architecture, and so do the lot of Azure IoT solutions follow the Lamda architecture. So what that talks about is a Lamda architecture is a framework that is put in place to achieve or implement these kind of solutions. That framework provides reliability, and also the architecture that you need to implement that this kind of data moving components all implemented together. So Yeah, so the Lambda architecture basically has covers three layers. It covers the batch layer, the speed layer, and the presentation layer. So so what the batch layer is all about? It's all about once the data is stored, how can you what can you do with it? And the speed layer is all about when the data is in move, what sort of analytics you can do with it. And once the data is stored, you have the final presentation layer, that you can that you do the visualization of your data, so that humans can read the data at the end. So those kind of framework is really good, and it provides the it provides historical analysis of the data, and also do the real time analysis on the hot path side of things as well. So it provides really good flexibility in implementing those kind of architectures. So in my project, so in this pet project, I did it in few phases. So in this video I'm gonna be talking about the phase one only, which is getting the data into the cloud using the Azure IoT and the other services around it in Azure. So this so what I had was, I had this, like I said, I had this IoT, actually a smart home device, and the device is connected to it, and I had the rules to say, like, when the pantry door opens, turn on the pantry light, and if there's a motion in the room, I had like music playing, and I had the light turned on if it's dark, and etc. So those rules can be configured within the IoT devices, within these smart home devices, and the discussion today is all about, after that, how do you get the data into the cloud, right? So how I approached it was, I had Azure subscription because I started playing with Azure IoT side of things, and I wanted to get a use case, how I can nail this thing quickly, and I want to do it in a practical way. And that's how I got. So I got this Azure subscription, and then I created an Azure IoT hub within Azure, and then I wanted to connect my devices into that. So these devices natively didn't support, and it's a pretty locked down devices, and I couldn't get them talking directly to the Azure IoT hub. So therefore I had to write a brokering application. So luckily I found out that my device did have a web service that I can this wearer device did have a web service that can that I can call the web service and get a snapshot of the current state of the devices. So that helped me to write this application, and I called that web service every 45 seconds through this web application, or it's a .NET application, and I sent every 45 seconds messages using MQTT to the IoT hub. So once I get the data, I got the messages receiving to the IoT hub, what's next? So I had a look at what we can do in this architecture. We have a service called Stream Analytics provided by Microsoft Azure that you can do propagation of the data, and also you can do real-time analytics on the data while it's in the movement. So what I did was, as it is in the movement, I put that same data into Power BI, and also I stored the cold data in SQL database, in a SQL database for later analytics afterwards. So that's about my architecture, and so the results after configuring all these was amazing. So I got some analytics, or the visibility that I got was cool, which I never saw in previously, right? So all the temperature variation in my house in different areas was there, and what's lead running is the garage temperature, because garage temperature varies very dramatically because it doesn't have any insulation to it, and all the other room temperatures, they vary in different ways, and the behavior is following a very good pattern. You can look, when you look at the data, you can see there are sudden hikes. That's where I have turned on my air conditioner and got the temperature into a certain degree. So those kind of things are very running in a very in a good pattern, and those kind of things are can be seen in these graphs. Also, it got some power consumption in what's graphed in here as well. So also some time around like how much time I spent in the house and out of the house and etc. Also on the right hand side, you can, because I have the data in the backend, I can actually create as much as graphs I want and customize the graphs however I want. So I created dashboards for each room because I have different sensors in each room, and I got the visibility of how the temperature varied within the room, the motion varied, and the light variation, and the humidity, and the power consumption, etc. So that kind of visibility is really great, which I didn't have before. And yeah, so let's go ahead and have a look at some demo how it's looking like. So I'll also show you how it's actually looking in the actual system, how I implemented. So this is my Azure subscription, and so if I go into the resource group, you will see that all the objects in phase 1 is stored in one resource group, and I have the Azure IoT, and I also have the stream analytics in at the bottom. So I'll first go to the Azure IoT side of things, and I'll show you what we can see there. So I have I'm still in the daily free limit. I'm in the free tier on the IoT side of things, and the brokering software that I wrote and that which is running in my house, because I have a server running 24/7, and that's running in one of the virtual machines there. So that's because I'm doing the brokering, I can reduce the number of messages I send to the IoT hub. And if I send it one message every 45 seconds, then I can still stay within the limit of the free tier. So I don't spend any money on the IoT hub, and I'm still in the free tier here. So if I go to the usage side of things, and if let's say first I'll look at the devices connected to that. So I currently have only one device, which is one of them, and that's the other one is a test device that I connected, which is currently not in use. And if I look at like the matrices and everything I'm getting, so you can see like it's currently receiving messages constantly every 45 seconds, and it's going as smooth as it can. So like that, it's receiving messages and passing the messages down the pipe. Also, I've got some monitoring configured. So if the IoT hub didn't receive any messages for 5, 10, and 30 minutes, I'm getting emails notified there's something going on. Have a look at that. Once in a while, like 2-3 times throughout. So I ran this for over a year now, and I didn't receive. So I received like 3-4 times where I had some issues, and all those were notified very quickly, and I managed to troubleshoot that pretty quickly. So that's the Azure IoT side of things. You can do monitoring, and you can also do device management, which I don't use in this case, but those are the capabilities that IoT Hub provides, and I'm still within the free tier. Also, it provides secure and reliable messaging platform for the devices. So once you get the messages into the IoT hub, you get the stream analytics in here. So with the stream analytics, it also has some monitoring. You can see it's running at 70% and constantly receiving messages and doing the processing based on the scripts that I have written here. And what it does is it has one input again from the IoT hub, and the outputs, we have 4 outputs, which is the Power BI, which I'm putting in, and I'm pushing the data to a storage account. I'm also pushing the data to a Vera, the SQL table. So that's that, and yeah, so that's basically the stream analytics, and I'm running this in a paid stream analytics because you don't get that for free for running. So yeah, that's a paid version, and also the SQL is a paid one, and I'm spending like $6 a month. And the SQL, you can see it's currently at its 1.12 gigabits, and I'm still at the very small tier, and the DTUs at that is pretty much enough. As you can see, it's enough for my workloads. So that's the SQL side of things. So let's go ahead and have a look at some Power BI dashboards. So once I get all the data, you can see this is running over a year, and I'm getting heaps of data collected from the sensors. And all throughout the year, this is how much time I spent away, and this is how much time I spent at home. That's pretty cool. So to get that kind of data, and also the power consumption, because there's so much data, that's why it's not that clear here. I'll show you how we can filter out these things. But anyway, this is all what we were looking at. All is the cold data here, right? So I wanted to show you some hot data here. So as you can see, this is doing this is doing some analytics on the hot part and providing this dashboard here. So as you can see, I'm currently sitting in the office room, and I have a motion happening in the office room because I'm sitting there. And also I'm using some power in the office table, and that's why it's showing me 108 watts consumed at the moment. And any other areas, there's no motion at the moment, and I can see some kitchen's motion happening as well. So like that, if you hang around for a few seconds, this should do constant refresh as it goes, because this is doing real time. As the messages pass through, it will update the data as it goes, as you can see. So that's the hot path analysis using the stream analytics. And yeah, so in Power BI you can do that real part and real time analysis, and the cold part, which is now I'm going to be looking at. And because I have the data, I can do heaps of dashboards kind of thing. So I can create a garage inside dashboard, and I can create a kitchen dashboard and office room dashboard, etc. So if I go to the kitchen dashboard, you can get some data of that this way. So the nice and cool thing is in Power BI is the natural query language, which I'm gonna show you now. So because I have so much data, I can filter out them and create some dashboards specific to that. But what's cool about here is the natural query language, right? So I can get the kitchen kitchen data for this month filtered out, and it will filter out the data for this month, and it should present me the data for this month. So it's up in here. So starting from April 1st, we are going towards this day here, today, April 22nd. So all the data, how the temperature varied in the kitchen, and the kitchen motion, and the light, and etc. So yeah, how much time I spend in the kitchen, that's about that. And how much time I have left my pantry door open, which is 2%. And also how much time I spent is actually 12%. And so let's go ahead and do some more queries. So let's have a look at some other queries here. Let's look at the garage temperature sensor. Let's look at some data from the last year. So I want garage temperature versus UTC time, and I want that in a line graph on 21st June 2017. So like that, you can go for a year. So you can go for a day, or you can go for a month in the last year, and you can query as much as data you want, and then you can get the data you want here. So that's pretty good, because you have all the data you need in the backend. You can also get like power consumption data, like I want to get office room power, actually office room, I want to get the office room, actually I should say office watts, yeah, and versus UTC time, in line in last week. put it that, and you can see that that data going like that. So if I do in this month of this month, and if I do this month, then I'll see some hikes here. But this is what I want to show you. So this hike is because they are all patterns, and I can see some patterns, some hikes going here and there. So that's because when I turned on the printer, it takes a lot of power at once, and then it takes away, it goes back to the normal. So this is how much time I have turned on my printer this month. So like that, you can look at the patterns and then you can get some insights out of it. So pretty cool stuff. So that's about natural query language in Power BI, and again, real-time data here. So yeah, let's go back to the slides. Yeah, so that's the demo I wanted to show you. So a few things I learned. So I had with the message, or with the data getting into the cloud, it wasn't a big issue, or it was straightforward. So I used IoT and Stream Analytics, and I had event tab, but it was like IoT was the best case for that. But when after getting the data, I had so much choices in terms of storing the data in Azure. So Azure provides different storage mechanisms, and this and the biggest question is, what's the storage account that I should use, or what's the storage type that I should use to store my data? Was the biggest problem I had. So so the options that were in the table was Azure SQL Data Warehouse was there, and it's a big data storage service. So if you're looking at maybe storing more than 5 terabytes of data, and if your volume is that much, and also if your velocity of the data is growing that big, then it's something that you should look at storing in the SQL Data Warehouse. And then I had Power BI. So in that case, because I'm talking about a small amount of data, small speed in terms of growth, I could Azure SQL Data Warehouse will be overkill for me, so I took it out. Power BI was as an option. Power BI is a good temporary store, but it's not really good recommended permanent store. So that because of that reason, I took it out. And Azure's data lake store is a petabyte scale storage provided by Azure, and it's overkill for me, so I took it out. Few more options available. Storage accounts, I can use the table side of table service within the storage accounts to store. That would be the cheapest to store the data I had got, but I didn't go that way because the how you want to read and write the data wasn't that straightforward from the storage accounts. And Cosmos DB is a good global distributed NoSQL database because my data set was more relational data set. I wanted to store it in a relational data store. So the store that I used was the Azure SQL database, and that goes well. So few key takeaways from the session. From the video. So Azure services are like building blocks. You can bundle them, or you can block it together to create scalable, reliable solutions, which can be done in production level. So it's really good services, and a lot of potential for developers to be really creative in making solutions out of those services. So thanks very much for watching this video, and I've got a few more faces which I'll put them in different videos later on. Thanks.